stores, and I saw this tube with a small tube buff. I asked the foreman what that meant. He said, that's 2 squares. So I said, well, what is 2 squares? So he draws 2 by 2, show me 4 squares. 4. And I said to him, it doesn't make sense to me.
What on earth do we have empty squares for? If it's a square, there must be some value there.
You can take a square, if you run the numbers in normal, 1, 2, 3, 4, 5, 6, that is uniform in. But when you total them up, each row, each column, each diagonal, you'll find they add up different. Putting numbers in random, we come up with a uniform output. Every line, every column, the 2 diagonals come up precisely the same.
Random numbers in squares will produce a uniform total. John Searle would soon call this the law of the squares, nature's way of achieving order from chaos. This led to Searle's revelation and gave meaning to his recurring nightmare.
At the age of 14, I looked at my dream. It's a game you all probably know. We call it hopscotch. The first dream, as I call it, is going to school. On my way to school, a 1.5 mile walk, I would pick up all the children, and just before we get to the school gate, we have what we call a hopscotch patch on the road itself. And it consists of 3 squares, 4, 5, then the odd one 6, then 7 and 8. Now, it's always that type of pattern, and there's a reason for it. I've obviously been playing with all the children. It's now my turn. I've reached the point where I throw the pebble in square 3. I have hopped to square 2. My left leg is firmly on the ground. The right leg is now up in the air, about to move across square 3, where the pebble is, into square 4. Suddenly, all the children vanish. In the picture now comes an entirely different ingredient of a steamroller. The village steamroller, the only mobile object I've seen outside a horse and cart. This time it's coming at me from the top of the squares towards me, and it's many times bigger. We have the roller done in 2 massive sections, and it's coming to me and it's saying, stop, think, act. If not, you had it. It's telling me by my leg movement that it's not square 3 I need. Go to square 4. It's square 4 that you've got to calculate out the ingredients. Here is the story of how to do it mathematically. And of course the dream was telling me everything I wanted to know. But I had to find those answers. I had to relate what the dream was saying to what I was trying to do. So it was a slow, tedious job. And of course I got the sums wrong on a number of occasions on the start.
From those numbers, John Searle had the exact amount of each ingredient in the rollers and rings of his generator.
Now, every 1 square represents a quantity of a material. And that's very important. This is precisely how I developed the SEG. So I copy nature in every way. I work at trying to think how nature's doing it, and then produce this object.
The first recurring nightmare had become a dream with meaning. Searle's revelation continued with his second recurring nightmare.
This time it relates to what I'm doing on the way back from school. Here, my job in the evening, after I changed my clothes and had a meal, I have to put the ladder up to the loft, the shed, open the door, get the straw, go and bed the hens down for the night. Now, when I get up this ladder, which is many times longer than normal, the door opens, and now instead of bales of straw, straw stems are laid out as struts of a structure. I am now standing towards the middle part of all this structure. Then suddenly the rim is blazing away afar, so massive that no one could put it out, and it's all around me. but something says, have no fear. You'll be lifted out from the center of that flame.
John would interpret the second dream to mean that the device would be circular and have many struts moving out from the center to the rim. Climbing the long ladder meant understanding the infinite combinations of numbers in squares. Then he would break through the trap door and be at the center of the ring made of straw. The fire meant that there would be great energy at the rim of the device. World War II had ended, brought about by the most devastating weapons ever conceived. The product of those lofty minds who 20 years earlier wondered what would happen if you hit a single atom hard enough. What kind of energy was stored in this tiny place? The answer, they thought, is the source of all energy in the universe. The practical answer was bang. In fact, the biggest bang mankind could ever devise.
Einstein opened the door a bit further. Like most people, they come up with a wonderful formula. Einstein did. And then he stops at that and says, there's no way you can get this massive energy out of an atom. The cost would be too high. It's not worth it. Then you see, you get another person comes along and thinks about this. Oh no, just bump it with a proton or a neutron.
His job at British Rewinds introduced John Searle to some of the vocabulary he would use the rest of his life. Words like volts, ohms, amps, and watts.
The first job that really got the dream moving. And it was a simple task in Gravesend Road at the British Rewind Limited, where I was apprentice, and my job was to learn to strip motors, strip the coils, measure them, and count the turns, and then remake a new coil and put back, and the rotors as well. So I came into connection with motors for the first time, electric motors.
By 1946, John Searle had a different idea. How could this energy be tapped without smashing the atom into bits? His idea was a completely new generator design.
We didn't call them solar effect generators then, but we were just trying to produce a generator to run the house lights on. Something simple, because I felt that the big generators at the power stations were a waste of money. Would present to us vast pollution problems in the future. So the whole idea was to get something simple, not difficult to produce, and produce electricity.
Basically, the design is a conventional generator as far as how it looks. You've got a magnet passing by a coil, and all generators of electricity are based on magnetics and coils. You can pass a coil by a magnet or a magnet by a coil, but that gives you your deflection in the electron flow and the force in one direction.
I already knew most of the fundamentals. What I was doing here was trying to get rid of the petrol engine or other devices to turn the generator. That was the objective.
This led to his first experiment conducted at home on a kitchen table with his landlady present.
So what do you remember?
I remember we must have had the house here because I'm looking at the distance at the end of the road, and it was this side all right, and I think it must be in this area, and it's gone.
The first model that was built by John Searle at the age of 14 and a half, after receiving some inspirational dreams, was assembled on a kitchen table with his landlady's permission, and he put it together and then started to load it as a generator. So let's put a light on it, let's put a cooker on it, let's put an iron on it, let's see what it'll hold and how much it'll do before it bogs down, heats up, and burns up.
Of course, that was a bad thing to do, indoors. You should always do experiments outside, as I discovered.
Well, as he increased the load, at a certain point, the temperature at that time mysteriously dropped down to close to 4 Kelvin, which is almost absolute zero. And when it did that, it became superconductive, developed its own gravitational field, we found later, and hit the ceiling.
And it was on the ceiling. And I said to the landlady, I said, that's a stupid thing. What's it doing up there? She said to me, you told me nothing would happen. And it had cracked the plaster, because they plaster ceilings. It hit really with force, and it was holding that.
Carrying all the wiring and the cookers and the irons behind it, dangling down.
So I, stupid enough, got a ladder, go on it, grab it, and then I couldn't let go of it.
And as a result, his hands froze to the framework. So the landlady put a screwdriver in to stop it. And luckily it didn't shatter it. And then he'd get his hands off of it. And that was the first experience of it levitating.
Twice he conducted the same experiment at number 30 Crawley Road, London, England, and both times had the same startling result.
I thought, well, lead is heavy. Let's put some lead on the bottom.
Yeah.
That'll keep it down. Again, I found I was wrong. I've no increase in weight. I've increased the density. Now there was more energy.
And it went down quicker. Not only did it go quicker, floors are stressed downwards, never upwards. The force that hit it, split through the plaster, timber, out through the tiles. The tiles were also stressed inwards, not outwards. And it just went through like shelling a pea, and out, and away.
Where'd it go?
We don't know. Just all we know, just went on and on, but not right away. When it was clear the building, it hovers. And that's where trouble number 2 comes in. You see, people had their sets off, radio sets off. They were off, absolute turned off. When that starts to glow, the radio sets all come on. So then you haven't turned them on. They come on full blast. And the din it makes. And of course, I wasn't a very popular man.
It eventually shot away. And I was taken to the police station and given a free home accommodation.
His new idea about tapping the energy of the atom resulted in the destruction of his home at 30 Crawley Road.
It was an accident that happened, not intended or planned. Unfortunately, some people didn't like it, and they chucked me into a place where I'd be secured and wouldn't blow holes through roofs and that again.
What was happening to cause this simple generator design to quickly overload and lift off the kitchen table? Apparently this was a new idea, but even the inventor could not explain what happened.
It was a learning curve I was being forced to follow. What it wanted to know was how electric motors were done, how they were wired and that, and the relationship. There are 2 key issues.
The 2 key issues are electrons and magnetic fields. John Searle understood the basic principles for generating electricity. He knew electricity was made up of electrons traveling down the wires into our homes.
To generate, you've got to have electrons for motion, great motion. That's why you go to the rare earth.
The basic components, the primary component is a rare earth. And it can be, although it can be any of the rare earths, the component that we use is neodymium. That's element number 60 on the periodic chart. And that unit puts out an excess of electrons for some reason. And it will also replenish them very easily.
Rare earth is the greatest weight of the whole materials that you're using. That has got to hold the mass of electrons.
John Searle's idea was to find a way to ease those spare electrons out of the structure and use them. Instead of smashing the atom into bits, why not tap this vast electron reservoir by using magnetic fields, same as any generator of that time?
So I say to myself, if you can release all the energy with a simple particle, surely we could ease it out gently by tunneling it in and giving it something to run up. So if we put a straight line, magnetic line, through, and the electron spins around, all this energy is spinning around and come out, we'll get a constant flow.
Tunneling into the atom using a specific magnetic field will cause the electrons to move in one direction, and they can be collected and used.
With production of electricity, you have 2 choices. You either rotate the magnetic field or you rotate